Yeah, you're welcome to today's class. We have actually gone a very long way into this project, and we have succeeded in getting all the 7 floors. So we just need to get the final structure. That's a very small structure at the rooftop. So with that, we are done with the model. So that's what we are beginning to doing today. We finish it and we assign properties on this structure. So stay tuned. And if you have not subscribed to my channel, I would beg you to just click the subscribe button and the like button as well. Then turn on your notifications so that each time I post educative videos like this, you'll be among the first people that will be aware of it. Okay, so let's dive into today's um, project. So let's revisit the architectural drawing. So now this is where we'll be focusing this night. This is what we'll be focusing today. Okay, so at this final roof level, we have some portion of this building being projected, and also they were able to carve out a room at the rooftop, and of course the staircase which led to the room. Exactly. So we are going to be projecting the members that we need to project, and we leave the ones that we don't need to project. So if you look at these walls here, so we see this is just a block wall, it does not have a column, so we don't bother ourselves with that. Okay, so we just focus on the columns that are being projected. If you look at this front view, which is this view, you see this column here is projected, which is this one. So we project that column, and you look at this block wall here, the half of it is projected. So that's this block we are seeing here. Okay, that's that block you are seeing there. Okay, so we are going to project this column, that column, this one, that one, and this one, all these columns. So we are just going to be doing that immediately. So now we start from here. I'm going to show you the way we go about it. Start from here, this and that column. These are going to be projected. So quickly implement that in our model. Okay, so now for us to work on this, I'm going to be showing you the easiest way to do that. We can just hide. Staad.Pro has a feature where you can hide, a feature that allows you to hide some members, and so you'll be able to work on a particular floor you want to work on. So I want to work on the last floor, which is the roof floor. So I'm going to hide the other floors. So see what I'm going to do now. I'm about to show you. I'll select the last floor. That's the rooftop I want to see. I'll click back at the isometric view for me to be sure I highlighted all the members at that floor. Then I'll click on selected objects. That helps me to hide the rest except the ones highlighted. So now at this point we're going to be extending those columns as indicated in the architectural drawing. So let me select the node. Now the nodes, this node is going up. Yeah, this other one is going up. Hold down the control key. This one is going up. Yes, this one is going up. This one, yes, it's going up. Okay, this one is going up as well. It's going up. Okay, so yes, this one is going up, and the one opposite, this is going up, and this one opposite is going up. Okay, then the one after it is going up as well. Now this one is going up. Okay, these are columns that are going up. Control C, Control V. sorry, select this, and this. Control C, Control V, 2.6. Has been added. So let me just click on the beam to see. You have to be very careful so that we don't join the wrong nodes together. This one to this to this, this is to this, and this is to this. Okay, so of course these ones are going to be joined together, while this one will be joined together. So they will now use block work to carve out what they want to carve out here. Okay. So for me to have my roof, I think I need to also close out some things there so that they will have the roof slab there. Everything is slab. There's no aluminium anywhere, so everything is slab. Okay, so for this place to be slabbed, to be able to be slabbed, I have to link up some beams to enable them to do that. So I'm gonna link up this to this point. So for me to do that, we need to confirm dimensions from here to here, 2.52. Then I will get my node numbers. Okay. So I want to insert a node here, 219 to 223. Insert node. Yeah. I'll put 2.52. Add new point. So okay. So it's not correct. It's not correct. Sorry for that. I'm going to say undo. So the 2.5 is supposed to be from here, from 223 to 219. So let me dimension this one. That's 404. 4.04 minus 2.52 is 1.52. So that's what I'm gonna put there. Sorry, insert node. 1.52, right? 1.52. Put 1.52. Add new point. Okay. So that's that. I'm now going to join this to this. That will enable me to be able to put slab load there, because that place is going to be roofed. It's still the same concrete roof they are going to place there. With this, we are done with the modeling. We are done with modeling with this. So this is the rooftop. The whole of this area is a staircase and landing, and from here they enter into this room. Yeah. Okay, that's good. Then for this place, I'm supposed to create a node point that will enable me apply the load coming from the water tank. So I have two nodes here. So what I need to establish the ones for this place. So let me get the dimension. Let me do always out to out so that I will get the mid span. That's 0.85. 0.85. So I'm going to offset node. I'm going to offset node, select node cursor, Ctrl C, Ctrl V in Z direction, 0.85. So the node is there already. So this place is where, if I'm applying the load, when we get to application of load, it depends. If I'm applying the load in form of point load, I will put the point loads on this node number, still 4 nodes. But if I'm applying it as area load, then I will need to close it up and apply it as area load. As the case may be, when we get to loading, that would be in our next class. We'll be doing loading of the structure. We load all the loads, do primary loads, and we do load combination, then run analysis. Then in other classes we begin to do member designs. So if you know you have learned something, like, click that like button, like this video, just like this video. It helps the YouTube to know that the video is of value and useful to the audience, and they will begin to push the content to others and suggest it to them. So just give me a thumbs up, like the video and comment. You can also put a comment, a positive comment. Yeah. Okay, so let us begin to assign. Let me first of all bring back the whole structure. Yeah, this is the whole structure. Let me hide the node numbers. Don't need them now. That's good. Then the dimension removed. So this is our model. Behold our model. So let me first of all assign support. I'm gonna be using a fixed support, yeah, for all my columns. So I'm gonna select all the nodes at the support and assign the support to them. Assign to selected nodes. Make sure that one is what is highlighted. If you highlight assign to view, all the nodes in this structure will be assigned a support, which is not correct. So if we choose use cursor to assign, that means any node you click on will have the support. So but in our own case now, what is better is to select assign to selected nodes. So and I'll click on assign and click OK. So that's support for my column. For this our car park area, we have these three columns as a circular column. So we are going to also we go with that. So we don't affect the aesthetics of this structure as proposed by the architect. So we go and do that one first. Okay, so I'll go to properties. I'll click on define. So we have circular, rectangular, T, and the rest of them. So we need to do circular first. So let me use 0.5 as the circular, 0.5 as the diameter. That's 500 mm as diameter. So when we design, and we can always change the section properties, the size and the rest of them. So it's not cast to stone. So it's a circular member. So this circular member, if you look at the drawing, you come to the elevation, you see that the circular, let me check where we can get it clearly. Okay. I noticed somewhere in the drawing that this circular column stopped at this ground level, so they didn't continue with the circular columns, you know. So okay, if you see clearly from here, from the plan, see circular column here. So but for these other levels, you see it's no longer circular, is a rectangular. So it's only our ground level we have that circular column, while we continue with our normal square column. Okay, so we are going to select that level that we need to work on. That's this level. Select this level, click on selected member. So now we have three columns. These three columns, sharing that property. So I'm going to assign these to these three columns. That's fine. Okay, then now we go to define again. I will assign. Let me first of all try. They might fail, but let me try them first. Let me just try 225 for all the columns. 225 for all the columns. So when we do design and it fails, we change this member size to 5. Of course, it is a normal practice that if you are designing a structure of that height, 7-story building, you can use a bigger section for your columns at the ground level, first floor, third floor, and then as we continue, you can reduce the size. For example, if we start with 300 from ground floor, maybe at fourth floor we change it to 0.225, something like that. So as the structure is going up, you'll be reducing the member sizes, because as they're going that up, they're not carrying much load like that, because load transfer comes from up to down. Whatever is happening at the roof level is being transferred to the sixth floor, to the seventh floor, sorry, and whatever that is happening at the second floor plus the one at the roof level will be transferred to the sixth floor. The seventh and the roof level plus the sixth floor will be transferred to the fifth floor. So just like that, they get to the ground floor to the ground. So the members at the ground level carry more load. They are the members bearing the compression and every other. They are the ones bearing the load, they are the ones carrying the building. So the columns at that level can be big. So as you go up, you can begin to reduce. But let us just use the same section, for the sake of this design. So when we now design and some members are failing, we will now know how and where and which one to increase, so that we'll be able to optimize in this design. So I'm going to add. So in this case, okay, let me just say Ctrl A to select all. Then I will hold down the Ctrl key to highlight these ones that I have assigned properties to, and I'll click on assign. Okay, I'm done with this ground floor. Since all the floors are going to be having these 0.225, let me just highlight columns from this to that point, and I will highlight, then click on select beams. Under beam parallel to Y, so it will select all the beams parallel to Y, all the beams, that's all the columns. Like I told you before in my Staad.Pro tutorial, that every member in Staad.Pro is seen as beam, but you know which one is column and which one is beam. So that's why if you're adding a column, you use the icon called add beam. If you're adding a beam, you use add beam. Everything is known as beam. So but you the engineer knows what you're designing, you get. So don't be confused when I say beam in place of column. It's because of the software. So I will now assign to this. So let me be sure that the one hidden is not part of what is highlighted. So I'm safe, I can continue. So I will just say assign to selected beam. That's fine. Okay, so now the other one is um, beams. I will assign property to beams. So the beams now, of course, will be rectangular. The depth of this beam. Let me just simply try. Okay, for my beams, I would like to change the. I will apply everything. Everything will not be the same. So I will put 0. 450 plus 150 is 600, right? 450 plus 150 is 600. So I will 0.6 depth. Then this one will be 0.225. Yeah, the depth. This is the depth. Look at the dimensions here. YD is the depth. YD is the width. So I'll add this. Then the other one will be 0.45. So I'll add it. Yeah, because our roof is going to be a slab, and if it was to carry all this aluminium roofing, I would have used 0.35 for my roof beam, but because it's going to carry a slab, let me just leave it at 45, 0.45. So let me say okay. So now I'm going to select this the first floor, second floor, third floor, fourth floor to have that big section of beam. Then this one, this one, this one, this one, this one, this one, this one. We have the, oh, sorry. We have the 450 beam. Okay, so we are done with assigning properties. So we can now check the three-dimensional view of our model. Okay, this is the 3D view of the model. Okay, see our circular uh, columns. Okay, okay. My mind is telling me that some of these columns we are going to fail, but it's fine. It is good. Let it fail first, and we can now, we know what to do to adapt about it. Okay, so this is where we'll end today. I have a Staad.Pro training package. It has pre-recorded videos programmed for 12 days. So if you want to learn Staad.Pro from scratch, you just need to get that package. That package is not what you're going to miss. It has a lot of things, and I made it in a way that each day you have something to do, something to practice. And this particular package covers both concrete and steel. When I say concrete and steel, you all know that Staad.Pro can design concrete members and also steel members. So I picked up a steel structure, designed it from scratch to finish. Designing of modeling of steel members, property assignment, loading of the steel members, analysis, design parameters, checking of utilization ratio. Then we now moved to RAM connection, which I used to design the connections of the steel. RAM connection is another software, but it is embedded in Staad.Pro. This is a connection design. Yeah, it's from Staad.Pro. Once you finish your analysis, just click on this thing, and it takes you to another software when you can do your connection design. So I also did connection design of that say structure, base plate, moment connection, share connection, bracings. I covered that. Then we moved to foundation design. So the package covers all of that. And I also picked a two-story building, concrete work. I designed them from scratch. The members were designed with um, RCDC. RCDC is another software. This advanced concrete design is another software that you can use to design concrete members, beam, column, slabs. So which I did with RCDC. So this program, if you know you want to learn Staad.Pro, I will urge you to just get it. The link is in the description of this video. Just check the link, and you also pick it. Then while during the course of the training, my WhatsApp contact is there. I also drop it in this description. So you can contact me, we can be talking. I will be directing you in case you have any issue or problem or challenge of whatsoever. I will be directing you, I will be with you throughout, and to make sure that you find value for your money. Yeah. So that is that. Then the architectural drawing which I'm using for this design, I've also added it in the description box. So this one is for free. Just pick it up, and for your training, for your practice, because I expect you to follow me as I design this building from step to step. Of course, I told you it's a project. It's actually a live project somebody gave to me. I picked this drawing from an architect, and I'm designing it for my client. So I'm going to develop design reports and drawings for this design, where I'm just trying to do a kind of video to show how I'm moving with the project step by step, so that you can learn from it as well. So that's that. If you have gotten something from me, from my channel today, from this video today, just like my video, like the video, give me a thumbs up, and please share my content with your friends, and where we shall just share and just share. Okay, see you next time. In our next class, we are going to be loading this structure. We load this structure, and do load combination, and probably we do analysis. Yeah, then before we start the member designs. Okay, thank you, and see you next time.